USB-C charger. Yes, let's figure that out. Yeah. Because your laptop, it's Linux, man. It's not Linux. Yeah. Would anyone happen to have a USB-C charger you'd be comfortable lending us for, what, 45 minutes, maybe an hour? A USB-C charger for a laptop? For a laptop. Yeah, for a laptop. That's a big one. For a laptop. Yeah, none of you guys have a USB-C charger for a laptop that we could borrow for the meetup for the next hour? No. Okay.
I probably have something out in the car.
Okay, I'm going to ask what's got here.
You don't let me know.
Okay, thank you. No one's got USB-C, so if you wouldn't mind checking. Please. Thank you. It's funny, as I was leaving the house, I couldn't find it. I was thinking, someone must have a USB-C charger. Thank you. Sorry about that. How's your power looking so far? Let's see.
We're at 41%.
Oh, still, that's the same.
It is? Was it 45 or 41?
It's 41.
Oh, okay.
Yeah. It didn't even dip, man.
No.
This thing's crushing it.
I think I'm even running Docker. Let me kill that.
I feel my laptop definitely, I mean, I'm typically running Docker, so I'm sure that hogs a lot, but I feel like my laptop, the moment you take it off, it just starts plummeting. But I mean, the battery's not dead.
Running a lot of Docker. Let's see what else I can kill. I mean, I've got a bunch of RAM being used, so something's.
Okay. Hopefully we do whatever you need to do.
I'm just closing a whole bunch of Claude sessions that I have open
Will
too.
the Claude so your battery lasts longer?
Well, because it sometimes spins up stuff in the background and then it just leaves it running.
Yeah. I've kind of been happy in that way, having it self-contained in the IDE. That's kind of what my talk is about today. I debug kind of like a really interesting, or at least somewhat interesting, performance problem using AI, and so that's what the talk is about. All right, I'll start wrangling people in.
Okay.
It's almost 7:15 here. Double check something before we make sure the mic is on.
Yeah, only 18 RSVP'd, and usually my metrics are if you get 2/3 of those, that's pretty good.
Yeah.
Never got back to pre-pandemic numbers.
No, it's not 2019.
Doesn't get any worse, man. But like 30, 35 is crazy.
Well, you expect that.
All right, I'm gonna switch over and start doing intros on this. Those are cool for me. I nagged him.
We're waiting on our USB-C.
Oh, yeah. Okay, we'll wait another 2 minutes. There's not one like buried down here somewhere.
I mean, there's USB-C. Oh, wait.
I don't know if that, so that's not, wait, this might work.
This looks
This
like
look-
power. It's power.
Oh, but, oh, is it?
It is, because it's yellow inside.
But this is literally,
That is yellow, yeah. I mean, I'm guessing this is the same as this.
okay,
It's funny that I look at yellow and I'm like, that's clearly a power cable.
okay.
It's
Well,
a yellow USB-C.
we
cable.
got
What
it,
else
it was
can you
just
do?
up here. We got what we needed.
It's too bad our USB-C friend is now probably in the parking lot.
So, well,
It's okay, I don't think he'll mind missing intros.
yeah.
Well,
Well-
I'll tell folks.
Let's nag people and then let's start.
Test. Oh, that's been a while.
You don't have to do that until I talk. Hello. Welcome. You're in the right place for San Diego Python. Glad you're here. I'm David. I'm one of the organizers. I want to thank Qualcomm for having us here, and for specifically the engineering development team, and Drew and Urivan. Drew might have let you in at the front door, so they're extremely helpful in making sure that everything runs smoothly with the meetup, and making sure everything's great Qualcomm related. And I want to mention that the pizza is sponsored by Cloudflare. So there was pizza outside before we came in here. And yeah, Cloudflare pays for that. Cloudflare makes networks and websites faster and more secure. They provide awesome tools like web app firewalls and DDoS protection, R2, which is like an S3 compatible storage, and a whole bunch more stuff. There's workers and all sorts of crazy stuff on Cloudflare. You should check it out. Like, they went from being kind of just a CDN to, I feel now it's like trying to eat Amazon's lunch. We'll see if that happens, but that would be awesome. Yeah, anyway, Cloudflare's network is absolutely massive. 95% of internet connected people are within 50 milliseconds of a Cloudflare node, so this can make your website super fast. Check it out, and the free plan is really generous. That's what the San Diego Python website is on, so thanks, Cloudflare. Awesome. I have a couple announcements, and then we'll get to our first talk. So there's a Saturday meetup, 10 a.m. on Saturday. It meets virtually. You can check the meetup page, or if you go to sandiegopython.org, there's all the details. It meets on Discord. If you need an invite to the Discord, you can get there from the sandiegopython.org website. On the website, there's a code of conduct. There's some other stuff on there. It links to our YouTube channel. So this meetup is streamed to YouTube. You can always check, if you miss a meetup, you can check the live stream. And usually there's, after a day or so, there'll be timestamps. You can like skip through to the talks and that kind of stuff. So it's convenient if you like miss a talk or you remember a talk from 3 months ago, you need to like review it, you can quickly find it. There's the Discord in there. There's a jobs channel in the Discord. Doesn't get a ton of traffic, but you know, it's a good place to post a job for your company if they're hiring or check out jobs. It's local jobs, that kind of thing. There's also channels for like web dev, machine learning, stuff like that. So check it out. A couple upcoming conferences and events I wanted to mention. There's PyCon US, kind of the big one. That's in Long Beach. It's May 13th to 19th. The core conference is only May 15th to 17th, but that's sprints and tutorials on either side. So this is, you know, I don't know what the post-pandemic numbers, but the pre-pandemic numbers, this conference would be like 3,000. What are the post-pandemic numbers? Do you know, Trey?
2,500.
Still 2,500. All right, so it's still pretty good numbers. So yeah, big Python conference, and it's relatively close. Like you can drive there. That's cool. In case you want to go somewhere further afield, there's PyOhio in Cleveland on July 25th to 26th. And DjangoCon US is going to be in Chicago this year, August 24th to 28th. So just a couple conferences from around the US. And the most important thing about the San Diego Python.org website and the meetup and everything about that is that you too can become a speaker. Yeah. On the San Diego Python.org website, the biggest button on there is the sign up to be a speaker button, where you can sign up to be a speaker. And I'm highly motivated to get speakers, because when we don't get enough, that means I have to prepare a talk. So I have a talk prepared for today, but it's only if time permits. So yeah, anyway, please sign up to give a talk. You can sign up for a future meetup. Everybody has survived who's given a talk, and we want talks at all skill levels. So whether it's a super advanced talk, a beginning level talk, intermediate, all those are great. You can do it, and it only has to be 7 minutes. Like you can do a quick talk if you want to. That's great. So please sign up for the next meetup. And I think without further ado, Trey, you're our first speaker. Trey Hunner is going to talk to us about hacking the Python REPL. I'm going to let you take it away.
Awesome. Yeah. Hopefully you can make this work.
Yeah, I can make it work. Although I will say, I want 2 extra minutes to do an additional talk before my talk on giving a talk. Because I'm just going to improvise this here. And the reason I'm saying this is, you know, David just pitched you on giving a talk. David, when did I ask you if you needed me to give this talk?
Tuesday, maybe?
Yeah, Tuesday. That was 2 days ago. I then confirmed yesterday which of the 2 talk ideas I was giving, which means I did not start making these slides until last night. Really, it was this morning. So granted, I did spend a little bit more time today than I wanted to on this, but I did also work today. So I'm setting the bar here for not saying that you can give a talk as excellent as my talk is about to be in as little time as I spent, but there's probably something you've mulled over that other people at this meetup haven't heard your take on whatever the thing is, whether it's code or something else. And in fact, 2 folks I met beforehand, I'm not going to say your names just so you're not called out on video, but you know who you are. It's your first meetup here. We haven't heard your talk on whatever topic it might be before, so it's not stale to us, which means when you get up here and give a talk on something for 5 minutes, you know, we're going to be interested in it, at least for a few minutes. And I mean, worst case, you bore people for 5 minutes. It's only 5 minutes, though. So that's my pitch on giving a talk. I guess one more thing I do want to mention. I'm giving this today with the motivation of hopefully giving this talk at PyCon maybe this year. There's no guarantee I will give it, because how lightning talks work at PyCon, they're absolutely 5 minutes at most. They cut you off at 5 minutes, whereas here, David's not going to cut you off at 5 minutes. We don't do that. But I'm hoping to give this at PyCon. You write your name on a board. They may send you an email and say, hey, we decided of the talks that are up, we'd like you to give yours this afternoon if you're available. Oh, we pushed you to tomorrow morning. And then you might be able to get up in front of a bunch of people and talk about something. So this talk that I'm going to now show you the slides for, you could also be rehearsing a talk for some, you know, future PyCon. In fact, PyCon this year is in Long Beach. Next year, it's also in Long Beach. You've got a whole year to prepare your lightning talk for next year.
Could I just get you to put this mic on your lapel
Yes.
or your collar or whatever?
Yep.
It's a pinch thing. That's okay. Don't worry. All right. Somebody said it was quiet. I think it was quiet for me too.
Okay, but let me know if it's no longer quiet.
Looking way better.
Looking way better. Okay, excellent. So now that I've given you that pitch on giving a talk, I'm hoping this will be about a 4 or 5 minute talk with a 3 or 4 minute demo, so about 9 minutes. The demo I'm hoping will be just 4 animated GIFs very quickly during the actual talk. Again, I made this today. Didn't have time to take GIFs. We're doing a demo. So I'm going to share some tricks that I use to enhance my Python REPL. I'm in the Python REPL all the time because I teach Python. Teach Python to teams, teach it to individuals, teach it mostly over the internet nowadays since the pandemic. But I'm always in the Python REPL. In a Python REPL or Python file, we are live editing things, live running things. We're playing with Python. So first, I'm using the term REPL to refer to what the Python documentation calls the interactive Python interpreter. It goes by a bunch of names, not referring to IPython, not Jupyter Notebooks, specifically the Python REPL that comes included with CPython. Sorry. Also decided to use a different slide program today, so it's a little fun for me. If you set a Python startup environment variable and you point it to a file name, Python will run that file as Python code every single time it starts a new REPL. It's as if you typed everything in that file right into the Python REPL. This trick has been around for as long as I've used Python. Decades, probably. I do not know exactly how long, but forever, basically. Until recently, Python had essentially the same fairly primitive REPL for decades, at least since the 90s. The customizations that you'd usually see in people's Python startup files were pretty much limited to defining helper functions or importing helper functions from usually the third-party library, or usually the standard library, actually. That was before the new Python REPL, which was introduced in Python 3.13. The new Python REPL has a proper block level editing. You hit the up arrow, you are editing an entire block of code, not just a line of code. And also pasting code just works. Pasting code used to be a mess if you had blank lines in your code. It just works now. And there's some other features as well. But there are also the keyboard shortcuts that used to work on Linux and Mac also work on Windows now. So when I'm teaching folks on Windows and a student asks how I cleared my screen because I'm not on Windows and I say Control-L, it just works for them. Did not used to work. By the way, I'm guessing there are keyboard shortcuts that work in the REPL that are you are underutilizing. For example, in the new Python REPL, if you hit Control-P and Control-N, you are navigating by blocks, not by lines. You can go up and down entire blocks with Control-P and Control-N. So the new Python REPL is great, but how is that related to Python startup files? Well, Lukasz Lange, during his EuroPython 2024 keynote, showed off the new Python REPL and poked around in its internals while he was doing so. He did not explicitly recommend that the audience do the same, but he did show us how to do it. So if you note that underscore prefix before Python, a PyREPL, that PyREPL module, that underscore prefix in it, indicates that this module does not have a public API or even a stable API. But just because PyREPL does not have a stable API doesn't mean that I can't use it in my Python startup file. So I set up my Python startup file to rely on this undocumented private module to modify the inner workings of the Python REPL every time a new REPL launched. And this isn't actually as bad of an idea as it might sound, because the worst thing that can happen is that in the future, I upgrade Python, the new version of Python changes this API in some way, breaks the REPL, I delete my Python startup file or edit it, and everything's fixed, everything's fine. These changes are limited to only the interactive Python interpreter, only on my machine. But the code needed for a lot of these changes felt very messy and very hard to maintain. It did not look good. So my Python startup file ended up ballooning to over 100 lines of code, which is why I then created a PyREPL hacks library, which is a wrapper around the PyREPL module. The 8 lines of code I showed you before are just 2 lines of code here. So my Python startup file was no longer anywhere near 100 lines of code. While I was playing with PyREPL hacks, though, I realized that I had a problem that I just invented for myself. To use this new library in the Python REPL, I would need to install it in every single virtual environment that I ever use on my machine, which would make it far more hassle than it was actually worth to use this library. So instead, I installed PyREPL hacks into a hidden directory, added that directory to sys.path in every REPL that I launched to modify every Python environment on my machine at runtime to include the new library. Again, not the greatest idea, but again, the possible damage is pretty limited. It's only going to break my Python REPL on my machine when I launch it. And it's not going to unless I upgrade my version of Python and something changes in there. So now my Python startup file looks like this, roughly. I have shortcuts to move to the first non-indentation character, to unindent the current block of code, to swap the current line with the line before it, the line after it, and to insert various code examples that I use very frequently while teaching. And I'm going to now demo, or attempt to demo those things by dragging this up here. Okay. And I will first copy paste some example code. So copy paste this. This is from an RST file here into the REPL. And you can see it's indented. This is a problem, right? If I try to run this code, it says unexpected indent. I can't run indented code. So I hit Shift-Tab and it unindents it. Unindents the entire block of code. That's kind of nifty. Also, if I want to take this, and I'm on this line here, I want to go to the beginning of the indentation, not the beginning of the line. Beginning of the line's over here. I could do that and go into the indentation, but I want to go to the beginning of the indentation. I hit Alt-M, I'm at the beginning of the indentation. And over here, same thing. I can jump to the beginning of that indentation. End of the line still works. That's a shortcut you should learn. That works in every REPL. Beginning of the line works. Beginning of the indentation, that didn't exist before. So little tiny tricks like that I was able to stick in my own Python REPL. Also, when I want my favorite code examples, like this or this one, I just hit the keyboard shortcut I made for myself to insert those, and I've don't have to type that all out as I'm teaching. So pretty nifty. I'm going to get back to my talk now because we're now done with that demo. Oop. So pretend those were animated GIFs. It was a lot quicker. Before I wrap up, I just want to note that you can also customize the Python debugger by creating a .pdbrc file, no environment variables needed for this. This is not a Python file exactly, and it is way more limited in its syntax that it supports. You can see these are one-liners. You have to shove everything into one line to get it to work, but it allows you to make aliases in the Python debugger, and some of these aliases can be very useful. So that's another thing you could do if you find yourself in the Python debugger often. I recommend making a .pdbrc file. So go play with the new Python REPL and try customizing your Python REPL at least a little bit in your Python startup file. You don't have to get into the internals of PyREPL if you don't want, but put something in your Python startup file to make that REPL more enjoyable. If you do try out PyREPL hacks and you have feedback for me, let me know. I'm open to ideas for more things to add to it that might enhance my own REPL as well. Thank you. Sure, yeah, if anyone has questions. Comments? Yep. All of the what I did? So the only thing that was in my bash RC was this. This was in my ZSHRC or bash RC, either way. This was actually in the file name that I referenced here. So I get to choose where the file is stored. I called it .startup.py. Maybe I should have called it .pythonrc or something like that, but it doesn't matter what you call it. You have to set the Python startup variable, environment variable to that. Then dump whatever you want in that Python file. It's just Python. So wherever you put that file, yeah, good question. Other questions? By the way, you can find this stuff on a blog post that I wrote about it as well if you look for my name on the internet, which there's my email. You can find my name from that. I think we're good unless someone else has another question. Yep.
Maybe it's not a very good question, but
go for it.
For embedded programming, as we were talking, what do you see the use cases about this Python startup from the point of have it related to boot up
Right, yeah. I mean, with embedded programming, I would guess that you're either not launching a REPL there, maybe ever, or if you are launching a REPL, you're launching it on your own to play with something, debug something, not for the sake of in runtime, in a production environment, out in the wild, you're going to launch a Python REPL. Because of that, I don't know if the boot time or the startup time actually matters. If you do imports in there, it is going to slow things down a little bit potentially. But I would guess it probably doesn't matter, mostly because you're only doing it when you actually opt into using it. If you run Python and there's a Python startup variable floating around in your environment, Python ignores it unless it's about to launch a REPL. In fact, yep. I mean, when you type Python and hit enter, you're dropped in the REPL. In fact, the one thing you can tell you're in a REPL is the 3 greater than signs at the bottom. That tells you in a Python REPL. So you see those 3 greater than signs, you're in the traditional Python REPL. Other than that, you're in some other environment. Yep, so entirely interactive. And because it's entirely interactive, it is not made for production, which means you're probably not running it in production. So I wouldn't worry about boot time. It's up to you. If you break things also, I wouldn't worry about it too much. It really is a pretty, even though it's not necessarily a good idea. I'm not saying you should do this, but if you do it, the damage that you can do is very limited because it's only for that interactive environment. Yeah, you're welcome. Yep, Drew. Man, what is it called? MARP or MARPit or something? I searched Markdown slides, and it was the first thing I found, and I thought, I'll try this one out. I don't love it. You may have noticed I kept trying to hit the arrow key, and it didn't do anything, and I had to click because I had to be in the right part of the speaker window to actually transition. But I'm wondering if I can fix that because it is a little bit hackable. You can at least put some CSS in there and such to customize stuff. But I'm going to play with it a little bit more, but I may end up giving up and going back to like Reveal.js or something, I don't know. Or Google Slides, possibly. All right, David, you going to give yours now?
No, we're going to do David Neal.
Oh, okay, excellent. I'm going to go to the Meet, which is over here, and let you, uh-oh, can I go back?
There it is.
There we go.
Oh, you have to ask to join?
I have to ask to join. I'm going to ask to join.
I'm going to allow it.
Thank you for allowing me to join this.
You're allowed.
I guess I could have joined from the San Diego Python account. There we go.
Okay, so that sounded like it was coming
Yeah, so do I mute? I'm going to mute myself now.
well, before you mute yourself,
Okay.
let's just make sure David's here.
David, can you hear us?
Okay, both of you.
Excellent.
And you're coming in good here too. So yeah, I think we're going to hand it off to you in like 20 seconds. We're just going to mute ourselves. And if there are any questions from the audience, I'll post them in the chat. How about that? And then, or do you want to do questions at the end, whichever is preferable to you?
I'm happy to take questions as we go, but which chat are you talking about?
Whatever one you want, but I was going to do the Meet chat, because you're going to have, I could do whatever you want. Or if you want, I could
Do it in Discord?
Yeah, I could do it in Discord if you want. What do you want?
Can you do it audio?
Oh, yeah, maybe that's easier.
Yeah, I can do it in the Google Meet.
Is audio.
Oh, as audio.
Yeah.
Right.
Just because he's probably not going to be looking at the chat.
I will do that when there are questions, and I will like run up here and unmute myself and then do it. How does that sound?
Excellent.
Should we full screen his?
Yeah, why don't you full screen his and then mute yourself and then tell him to take it away. Well, actually, tell him to take it away and then mute yourself.
Yes, I'll tell you to take it away and then mute myself. That's a good order of operations. Thank you. Take it away, David.
And then I'm going to bump up his volume.
Thank you, Trey. Okay, it's all very complicated, isn't it? Right, good evening, one and all, from very west of West San Diego. In fact, I noticed that I was putting the date on the title slide there, which I hope you can see, and realized that it's a different date for you. So there we are. Previously, in fact, as long ago as last year, we were talking about PyTest and parameterization. Parameterization, you will remember, is multiple sets of one test being run multiple times with multiple different sets of data. So it's a very convenient way to run the same thing over and over again, but with different scenarios. Tonight it's the turn of fixtures. It's another useful term within the the PyTest ecosystem. The objective here is to surround our test functions with useful tools. So let's have a look at an example. The example code that I'd like to take a look at is a very, very simple one. So there's our bank account. Ridiculous piece of code in many ways. For anybody who's in banking, please look away now. We can accept a deposit, and naturally that increases the balance. We can withdraw money from our account. Banks are kind of reluctant to let us do that, but we'll try. That means we reduce our balance. And in there, we should log what's going on, because the bank likes to keep a record, and we like to know what's going on and make sure that they're giving us our money. So the bank account knows absolutely nothing about files, right? It knows nothing about databases. It doesn't know what time of day it is. Yet we're going to need to record all of those things if we're going to be a serious banker. It accepts a logger. As you can see at the init, we are taking an existing logger. We're accepting it by dependency injection. We are not creating our own logger within this class. Now, this is handy because we can test this class without needing to worry about whether our logger is running, etc., etc. So, without any further ado, let's have a look at the test file. If we have a balance of $100 and we add a deposit of $50, we can expect that we are going to get a balance of 150. Similarly, if we start from the same balance, withdraw 30, we expect a different balance at the end. And then finally, remember that rule. If we start with $100 and we try and withdraw $200, it probably ain't gonna work. So let's prove the case. On the right-hand side, you can see the test results, and you can see that we've passed 100%, except that I have my cursor in the wrong place, and it's only run one of those tests. So try again, David. And there we are. 3 tests on the right-hand side, 3 passed. Aren't we wonderful? Okay. Rather unrealistic, but let's run with the idea that this is how banks work. Now, when it comes to testing, you'll notice that we have the same line over and over again. Now, I don't know about you, but I absolutely hate this repetition. I hate the idea of boilerplate. So in the immortal words, there must be a better way. So let's have a look at introducing fixtures. So here at the top of this file, we have introduced a fixture. At PyTest.fixture. You remember last year it was the word parameterization. This time fixtures. Sorry, fixture plural. Fixture singular. Get it right. So what we are doing here is we are creating that bank account in one piece of code, and as long as we refer to bank accounts at the beginning of our individual unit tests, that value is carried forward. Now, be careful how you think of that. We'll come back to exactly what's happening in a minute. But what we're aiming to do is we're aiming to get rid of the repetition by adding a fixture. Now, notice the parameter name. Although the fixture is called account, and it looks like a function, and therefore you would expect to call it as a function, when we actually include it in our test runs, we only refer to the name of the function with the name of the fixture. So be careful about that. So let's quickly run that one. Oh, did the wrong thing. Try again. And there it is, 3 tests and working quite cheerfully. All right, that's all very well. We're using PyCharm. Let's go and have a look at the command line. So on the right-hand side, we now have the command line. Give ourselves a bit more space. And using UV because David ran a good talk on UV last month, so have to follow up with his excellent examples. And there you go, same result again, pass, pass, passed, everything's green. Life is happy. Now, just to fill in the blanks, there's our logger. Don't plan to talk very much here. What we're talking about though, timestamps. You want to keep track of time. I'm going to come back to this a little later on. It's not part of bank account. We're going to come back. We're not going to come back and talk about freeze gum, but we are going to come back and talk about times a little later on. The interest here is that we don't want to be making changes to our code. So we've got a helper function to take care of things. Here we are bringing it into our testing. Standard fixture. Now we've added a new fixture. We're adding this logging process in there. All the usual stuff. We're adding files. We're going to log to a file. We're going to have to give it a file name. And I think I'll just run the test first and then come back and explain some of the rest of it to you. So once again, let's use the command line. PyTest does some interesting things when it's running a test runner, but every time you change it, you've got to mess around with its settings. So in many ways, it's easier to do things from the command line. Okay, now we've got 2 fixtures. We've got one called account, one called logged account. What's going on here? I have run the UV, lost it for a moment, and it can show us that we are starting to set up our path. We're setting up our logged account, right? That's over there on the left. Then we are running our test called test deposit over here on the left, using fixtures. And so there you go. You've got an audit trail for your tests. Then we move on to testing the withdrawal. And once again, we've got a nice audit trail. Which fixtures are being used? Now that's a PyTest audit trail. Of course, we've got our log. The whole point of our log is also an audit. So sorry to use the same word twice. And there it is telling us we're auditing those 2 transactions, the deposit and the withdrawal. And then at the end, you can see this little piece here called teardown. And that is the exact opposite of these 2 lines at the top called setup. So I said I'd come back and explain things to you. Here's our fixture. Our fixture does 2 jobs. It will set up a test for you. That's all these things like organizing files. It will also tear things down at the other end. For example, closing the log. So a fixture can perform 2 functions. a setup and a teardown. Setup are things that happen before the unit test is run. In this case, something like test deposit or test withdrawal. And after those tests are finished, it will run the teardown. How does it manage to do that with just one function? Well, the answer is that, of course, it's a generator. So the first half, everything above the line highlighted, yield, is setup, and everything after it is teardown. Very nice if you are using files, because responsible programmers like us not only open files, but close them as well when we've finished. No questions so far, Dave. So now I would like to talk to you a bit more about scope. If we're going to do setup, sorry, thank you, David. If we're going to do setup and we're going to do tear down, when do we set up and when do we tear down? And this is one of the key points about fixtures, one of the most difficult parts to understand. By default, the scope of a fixture is called function scope. It only works from for one function at a time. So if we run our deposit test, it will do the fixture will do the setup first, then it will run the test for us, then it will do the teardown. If we then run the withdraw test, first of all, the fixture will run the setup, then it will run the test, then it will run the teardown. This is creating a consistent environment for each of the tests, but not a continuous environment. The source data going into each test is idempotent. I'm not quite sure how you pronounce that word. What it means is whatever happens in the first test doesn't affect what happens in later tests. And that's a good way to go. If you want to get rid of dependencies because you want to be able to test as a unit. Why do we call it unit tests if we're not going to test as a unit? So function is the default. Now, it's not always the best way to go. There are all these other options becoming ever more complicated as we go. But be aware, when you move to class, every test method inside your test class uses the fixture once. So they all share the same fixture. So in this particular case, when the test class starts, the fixture does its setup, then the class is run, all the different methods, one after the other, pop, 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 and then at the end, the teardown. So now you have lost some of that idempotency, if there is such a word. Now you do have a situation where if we had a test class and we had our deposit and our withdrawal in the same class, we would have to watch out that that the balance calculation at the end of the withdrawal took into account the fact that we didn't just start with 100, we started with 100 plus the preceding deposit. So you can see why function is probably a better way to go most of the time. But the more often you run a fixture, the more often you do a setup, and let's take an example like opening files, the longer the test is going to take to run. So if you can get away without opening files, even better. But maybe in certain situations, you can't get away without doing it. Maybe you can run your tests using a mock of the file contents to speed things up, but don't forget at the end to actually do it with a real file, just to make sure that your mock doesn't actually come back and mock you. The last two tests I'm not going to show you today, module wide. I think you can probably get the idea. The setup is done at the beginning of the test module. The whole test module is run, and then the then the cleanup is done for you by the fixture. And the same thing for the session. So if you are running a single test module, this has no meaning really. It's exactly the same as the module level test. But remember that PyTest you can run across all of the tests that you have, all of the test files that you have in all of the test directories that you have in your project. And so a session means we only do the setup once, we run all of the tests in all of the blah, 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 and at the end, we do the cleanup. So scope is important and very easy to trip yourself up, but at the other hand, yes, powerful. Why aren't you going back to there? Thank you. So returning back to this, this printout, on the right-hand side, there we've got the setup. At the bottom, we've got the teardown. In the middle, we've got the actual tests running together with documentation about the fixtures that are being used. And in the middle there, we've actually got the actions taking place being documented. Still no questions. Okay, I'm very happy with that. So yield gives us a generator rather than a function. Therefore, we have those two halves, the setup and the teardown. Now, what about we have several fixtures going on here? We can have a fixture which depends on another fixture. That's okay, nested fixtures. We can get that to happen. Fortunately, we don't have to pay too much attention to it. PyTest will resolve it for us. So here we have a directory structure, and you can see the option, the opportunity to have fixtures which call fixtures. The other nice thing is we don't get into too much of a problem. Sometimes we can get into problems with what's called circular imports and things like that. One of the nice things about Python is that it will deduplicate some of these issues where we have multiple calls on the same function or the same facility, the same module in that case. Talked about scope. Yes, good news. We don't have to wire that up manually. All right, let's have a look at what happens when we have multiple fixtures. On the right-hand side, running that test, and it doesn't work. Very good. Test transfer. Not found. If anybody has a bright idea, David, I will welcome it, because I suspect it's one of these things where I look at it and I won't see the wood from the trees. We could use one, but we don't need it, no. But we're not importing it. It's probably the issue. Should be importing that from. How did it work before if it doesn't work now? What does that mean? I'm going to just try this, David. If it doesn't work, then we are running. Yeah. No, it's still not working. Okay. Yes. Okay, let's do exactly what you've suggested, and let's move on to those rather than wasting time or losing time. As Trey suggested, there's a file called ConfTest, and ConfTest does have the advantage of being, you might say, a central store for where you would keep some of your fixtures, or helper functions if you wanted to use those as well. So here you can see we have an audit log moving into fixtures, an audit log fixture, sorry, and there we go, there's our account. So have I got my files out of order there, Trey? Let's try that. And so the payoff for this is like fixtures in general. The idea of a fixture is that you can have the setup built for you. You only have to write it in one place. You don't have boilerplate of having to write it in multiple other places in your test module, your test functions. Here, you can put it into a central file, and you can now call it from several test files. And when I say call it, good news, you don't even have to call it. PyTest will automatically go and look for a file called CompTest and will do the job for you. So you'll notice that I have cheated and I've called it comptest.1. You probably got the idea now that I've got more than one of those. So I shall put that now into my test file. So as long as it's somewhere in one of our test directories, CompTest is going to be picked up. Okay, let's try that again. On the right-hand side. Thank you, Trey. Now it's working. So we have picked up the account. Was it account that was missing? Account. Okay, I've forgotten where we were going wrong, but anyway, we've picked it up now, so we're all happy. Moving the other way, we can have a test function in this case where we call multiple fixtures. So you're not limited to only one. So account and audit log. Audit log is sitting there quite cheerfully in the conf test. So it's account. So if we start running this one, once again, it's working quite cheerfully. So here we have a structure where we have our fixtures depending on fixtures. We're relying on PyTest to resolve the graph, the network between the files. And we are relying on the central comptest.py file. Okay, something a little bit more complicated. Back to the slides. Here we have a conf test sitting in with all of our other test files, and we can run that from the ordinary test file. It will automatically pick up the conf test. Now, you remember what I said? You can mock your data source as much as you like, but sooner or later, you should run a test just to make sure it all fits together. Now, we're probably starting to stray out of the range of unit tests and into the range of integration testing, but hey, what's in the name? So here, what we want to do is bring in our databases. I don't want to mess around with that. So what I'm going to do is I'm going to use another conf test file. This one's going to use the same audit log, the same account, but now we're going to actually go through the long way around, setting up our schema. I'm very glad that AI helped me out here with SQLite. It's not something I use very often. And we've got our account. sorry, we've got our connection first to the database. We've got our account. We can write to that, inserting transactions into the database. And of course, at the end, right, we want to reset the database. We want to get rid of the data from previous transactions so that we can carry on with our new transaction in this consistent idempotent situation. So once again, quick cheat. Close your eyes. You can't see what I'm doing. And we'll overwrite the conf test with the more complicated one. Okay. Now we can run our testdb file. Another little cheat down the bottom. So on the right-hand side, there's our test. Now then, this time, we've got all the information about tests passing. We've got our audit log, which says that we've done our deposit withdrawal, etc. But down the bottom, we've got the time trial. We've got the speed at which these tests are being run. The ridiculous thing is, of course, they're all 0 because they're all trivial tests. They all operate very quickly. So I'll just show you that command. Apart from the U, which is over on the right-hand side, UV run test, run PyTest. By adding -VV to give us extra verbosity and -- durations equals 0, it will count all of the durations of all of the tests that take longer than 0 seconds. If you don't want to see them all, you can put, say, 1/10 of a second in there or something like that, and it will reduce the length of the report for you. You'll concentrate on the ones that take the longest. Which ones take the longest in our case? And the answer to that is that I need to put in front that. Sorry, lost my place. I'll find it again in a minute. All right. Okay. The one last thing that I wanted to point out today is in the conf test. Here we have a fixture to set up the audit log, which is going to last for the session. Here we have a fixture for account, and that is only going to last per method or per function. Here we have something that's not a fixture, it's just the standard SQLite. We set up the database connection for the entire session. Our account is only set up per function. And then down here, we have a special one. Our reset is set to auto use equals true. Now, auto use is one of the most abused facilities in fixtures. Auto use, as the name implies, every single time you run a test, run this fixture automatically. Use it every time. Unfortunately, a lot of people miss out on this and don't quite follow what's going on. There's one very simple rule, and that is it will not return anything. So you cannot use it for the average setup. if we have our average fixture, the average fixture returns something. In this case, we're returning a bank account. That means when we name it in our test, we are calling that function. But with auto use, we don't actually call the function, which means there's no way for auto use to give us some sort of return value and put it in the function. A lot of people don't seem to realize that one. Brian Ocken makes a particular comment about it, and in the documentation, saying it's not something you're going to use every day. But in the database world, actually it is. It's very useful. And this is something that we could discuss at greater length in future, but we don't have time for tonight. So you'll notice here that this particular fixture is not used as a setup at all. There is nothing before the yield. It is only used to clean up behind us. Right. I think I've covered all of this already. Brian Ocken said, yep, exception rather than the rule. It is purely a side effect. If you're a functional programmer, yeah, close your ears. It's a side effect. And it's designed to be a side effect. It doesn't actually accomplish anything in terms of communicating into the test. Okay, what have I missed out? What I've missed out is running this test here with our database. We've run it with memory. We run it using using a database in memory. Not all that realistic. So, sorry, I'm typing and talking at the same time, which is never a good thing for me to do. So let's try it now and see what happens when we actually run it to an SQLite file. Remember all those zeros before? Okay, we're still talking small beer here. 0.06 of a second is the longest. But if this was a real database, if this was going across a network, if this was going across the internet, the times are going to be a lot more significant. So you can see the idea of mocking your database or mocking your data source is useful in terms of saving time when you come to run your tests. Okay. So one more slide. Where do we go? We talked about fixtures, injection by function name, not by function call. We talked about scope, function, class, session. There's one missing in the middle there. Module, yield, and teardown. So you've got the setup and the teardown. You've got the two halves. Conf test, good way to share test files. You can share across test directories or you can share amongst test directories. You can have multiple conf test files I didn't mention earlier. So if you have multiple test directories, you can have one conf test in each of those. The fixture dependency graph is worked out for us. PyTest is pretty good at this. Usually the issues are to do with whether PyTest can see the files we want it to test for us. I didn't mention environment variables in terms of mocking the database or indeed in auto use. Another good use for auto use. So I think we will leave it there. I think I've run out of time, David. There are things that fixtures can't fix for you, and time is one of them. I've just alluded to time, but what happens if time is the data you are processing? How on earth do you test something that is supposed to happen in real time and still be idempotent, still have your tests consistent? Plenty of further reading if you want to get into it. I've also avoided monkey patching. I think the first part of that name indicates my attitude to it. You know, hey, we're the monkeys. If you're old enough to remember that TV program. Fixture factories, very much more complicated, and PyTest Django, a whole special area. Incidentally, with PyTest, with Django, if you are a Django person, do not get confused with the word fixtures. PyTest uses the word fixtures in quite a different way to the way Django uses it. Okay, anything else I can say, David? Excuse me, you'll need to come to the front of the room because I cannot hear you. Thank you. The issue there is which order are the two test files going to be executed? So because you have a dependency, I have to say that the solution is to take that session-wide test and put it into your conf test file at the highest level of your test directories. Because then you can guarantee it doesn't matter which order the two test modules run, your fixture will always be ready and accessible. Thank you. Have fun, everyone. Oh, good stuff. I'll jump over. Thank you.
Okay. I have no speaker notes. They're on my tablet. My like 10-year-old tablet that is just used for this, and then I turn it off for the next month. All right, awesome. So I'm the last speaker. Again, highly motivated. Get everybody to sign up to become a speaker in the future. This is kind of a fairly last minute talk. We had a late scratch actually. There was somebody else who was supposed to give a talk and they had to cancel. But I wanted to talk a little bit about something that happened just in the last week and a half or so with me. I was debugging kind of this persistent performance issue. I'd actually taken multiple stabs at it myself and failed mostly. Sometimes worse than others. One was a spectacular fail, but that was okay. And then I said, oh, I'm debugging performance issues with the anti-gravity. I'm going to get into what anti-gravity is, and we'll just go from there, I guess. So I guess the first thing is, what is anti-gravity? So this is Google's agent-first IDE. So what does that mean exactly? So agent-first, basically editing code yourself and kind of reviewing code that's written by the agent are kind of co-equal things in the IDE, I guess. Or even if I were to say which one is perhaps more important, maybe reviewing the code from the agent is more important. Oh, I should also say you can download the IDE yourself at antigravity.google. Yeah, that is the actual domain. Just antigravity.google, not google.com, just antigravity.google, whatever. Anyway, cool. It is built on VS Code, so any extensions that you use in VS Code or something, that's all going to be available. And out of the box, it works with a curated list of LLM models. I know that my slide says otherwise. Mostly those are Gemini models, but it also supports the Claude models. And then it also has OpenAI's GPT-OSS model, but there are ways to make it work with other models, like local models that you might have if you would like to. They don't make that trivial, but yeah, anyway, it's a thing. And the IDE is free, and the free plan for the Google models is reasonably generous. I actually got away with using just the free plan for a little while, and yeah, you can totally get your feet wet without paying, I guess is the right way to say. So I couldn't get past, I had to do the obligatory XKCD for this because if you've never typed import anti-gravity into your Python REPL, you should. And you get this actually, so kind of cool. Anyway, I'm gonna skip by it. We don't need to go into too much detail. Ooh, that's probably small. Well, okay. So this is kind of, you don't need to even look at this code. It doesn't matter. This is what the IDE looks like. And you can kind of see I have IDE type stuff on the left-hand side, and I have a ChatGPT-like interface on the right-hand side. And so these are kind of co-equal things that you might use. However, I don't want this presentation to be kind of like an ad for a Google product. That wasn't my goal here. I wanted to dive into something that actually happened. And this is something over the last couple of weeks and how I solved a real world performance issue. So this is kind of, yeah, that's what I wanted to dive into. So this is performance of a real Django project that I have, and you can kind of see right here, this is where I deployed a new feature, and you can see this is kind of oh, the caches needed to be warmed up, but then it kind of still settled into a higher plateau there. Maybe we'll say that. And I was deploying this at a low time for traffic, which is usually when I do deploys. So, this is about 30 requests a second instead of, peak traffic's closer to 100 on this one view. So that's kind of the traffic that I'm looking for. So milliseconds count, I guess, is what I'm saying. So that was kind of that's kind of where I was at. And kind of this is where I rolled back. When I was oh, performance is bad, roll back. So this is kind of, I rolled out a feature, performance was bad. I do have tests to test performance, actually. They did not catch this, because most of those tests were catching, n+1 query issues or generating too many queries, those kinds of things. Anyway, it's about 20, 25 milliseconds slower, which is kind of a disaster in this case. Okay, Google, fix it. So that was kind of my next step here is what's the problem? I actually did take a couple stabs at this manually because I've historically been kind of skeptical of performance issues being solved by LLMs. Actually, I've tried it a couple times. They've been bad is kind of the real answer. But in this case, actually, it worked out okay. So I asked the agent about it specifically. I specifically talked about the magnitude of the degradation, about 60 millisecond median performance on this view to about 85 milliseconds. I mentioned the specific pull request that introduced the issue. I even had kind of a theory because I looked, one of the things that I looked in my performance graph, the queries, which are the other colors that are not blue in this graph, those did not get bigger. Only the blue part got bigger. And so this is Python performance. which encompasses a bunch of stuff. And so I didn't add more queries. My queries weren't slower. Something that I did in Python made my view 20 milliseconds slower. Yeah, that's a lot. Anyway, so how am I going to fix it? I did prompt the LLM pretty. I gave it a lot. I told it, I'm looking at New Relic. It doesn't show any queries, but I had a very strong idea of what the problem was. I suspected that the problem was I transmitted too much data over the wire from the database, and it had to deserialize too many models from rows in the database into models in Python code. That was kind of my theory. And so, the LLM was like, oh yeah, that's totally the problem. You're right. And here's my fix for it. And I looked at the fix and I was like, this is gonna fix anything. But also I didn't fully understand the fix because it used a bunch of Django features that I'd never used before. So kind of two problems there. One of the things that I did like about it is it did create an implementation plan before I kind of let it do its thing. This is one of the things that I like about Antigravity is before it just starts writing code and stuff like that, it creates a plan. You can kind of edit the plan or comment on the plan or tell it, hey, don't worry about this, only worry about this one part that I'm working on, all that kind of stuff. I kind of just let it cook in this case. Normally I give it a lot more feedback, but in this case I was like, well, I don't really actually think that the plan is going to solve the problem. I was wrong. But I kind of just let it go. Also, I know Hobson's not here to chide me about my LLM usage, but I keep my LLMs a little more locked down for agentic development. I like the security features. I like that you can set Antigravity to prompt you on every command it's going to run, those kinds of things. Anyway, whatever. In the end, the change used, this is probably, it's actually not too small. This was kind of the big change. There was a couple other lines that it changed to use these features down below, but it actually used something that I'd never even seen before in Django, which is part of why I was confused, which are I can't even remember the name of what they call these, but basically this will result in an SQL case when statement, which I was familiar with this in SQL, but I actually didn't know that Django had an abstraction layer for this. But basically the end result of this is instead of, I was fetching a bunch of models and then looping over some models to calculate something for a set of models. And instead you could just kind of get the maximum value out of the database. But it was a little bit more confusing than that because this still isn't just using a max clause, which would make that really simple. I was kind of surprised, I guess, that deserializing models, and we're not talking that many, we're talking maybe a couple hundred worst case, actually took that long, but it actually did. The over-the-wire time from the database combined with the deserializing actually was about a 20 millisecond difference. It was kind of crazy. So yeah, relatively few changes here, and I deployed this change. I don't have the graph of, hey, I deployed this and nothing happened, but that's kind of what happened. Cool, that was kind of it. Yeah, this is kind of a thing that the IDE taught me, I guess. I was using the IDE. I didn't know that Django had this case when statement. I have no idea when this was added. I don't know if you know that, Trey. I was familiar with SQL case statements, but I just didn't know that there was an abstraction layer for it directly. Yeah, anyway, that's that, I suppose. Any questions on this? Go ahead.
I don't know if you've used it, but the plan mode in Cloud Code or Codex, do you know how this compares to it?
I do not. I do not know how it compares exactly. I started using this, I think, before some of those before Codex, I think, even existed. Okay. And I think that at least Codex kind of adopted it from other tools.
This is not a new idea. It's been around for months.
Yeah, months. Yeah. Yeah, so this is the IDE that I use for most of my Python and Django development now. But yeah, it's months old. Probably even maybe 6 months. It's crazy old. Yeah, and before I was using VS Code and I tried it with the Copilot integration, and I liked it considerably worse, actually. So I like Antigravity a lot better than that. And I'm not sure entirely whether, I think it's a combination of the models that it's using, but I think probably the bigger thing is just how Antigravity is set up to, with that plan mode and that kind of stuff, which I suspect that the other labs are just going to adopt because it works pretty well. Any other questions? Okay, I mean, that's it. This was a relatively short one. It was just kind of a real world issue that the LLM fixed for me and taught me about a new thing that I didn't know. Cool. Please sign up to give a talk. I did want to just give a thanks to our speakers, remote speaker David Neal, Trey, and myself. And thanks to Cloudflare for sponsoring the pizza and Qualcomm for having us. So thank you, and hopefully I'll see you next month. All right. Cool. All right, I'm gonna stop the stream. Oh, I should have maybe checked if somebody posted something. They didn't. Okay, I'm just gonna end the stream. Anyway, yeah.